Welcome back to the practical of the interfaces module. Here we have a chess implementation that we'll briefly have a look at how the code works. Most of the implementations have been implemented for this already. So we can see we have different pieces that we can move. And over here, we'll have a look at how to implement the queen, for example. So we can see, okay, it is, so here we'll see check. We can cover this over here, and then here we'll see we cannot move this. The implementation hasn't been done yet, so we'll briefly have a look at how each of the pieces work, the setup for the whole application, and what the differences are for each one of them, how we're using interfaces and so forth. We'll briefly go over the front end as well and how that specifically looks. We'll also have a look at some of the functionality like undo as well as quit, and how that actually works and how it touches on the purpose of using interfaces, and leading on to the next module, which is data structures and collections. Okay, so let's have a look at it. So firstly, again, like the tic-tac-toe, we have a very similar example, except this is much cleaner and a bit easier to read as well. So we have a range of different classes, very touching on similar to what we had in the tic-tac-toe. Again, we have a player class, which represents a specific player. That information is printed onto the screen. So like we see here, this is the player information, their ID, their score, the name, who's currently playing, and so forth, being able to set the score and set who's currently playing. And then we have a range of different other items in here. So like for example, validating the chess pieces. We have examples of using danger types to represent if a king is in danger, different states like check, checkmate, stalemate, and none. Models for saying if a king is in danger, a game manager that manages the overall game structure, that basically handles everything in terms of the game. We have an example of a board. So a board has a range of different methods, being able to initialize the board with each of the pieces that we see right over here. So each of these is a tile. So we represent this as a square with a mapping for each one of them. So for example, each of this will be a tile, A1, A2, A3, A4, up until A8. And the same goes for each one of these. Then on each of the tiles, we set a piece. And a piece is, again, whether that's a pawn or whether that's a rook, whether that's a knight, whether it's a queen, all of them are pieces, and each of them will have its own implementation about how that piece moves. So for example, here a knight moves in this way, while a pawn can only move forward, for example's sake. So the implementation of that is left to the specific of that specific type of piece. I have created a short readme here about how the game works, where each of them can only do one specific thing, and it has a set of moves. So for example, a pawn moves forward, they can move twice on their first time. They have a special move called en passant, where if a pawn moves 2 squares forward, while there's an opposition pawn, that pawn can be captured. Promotions. So many of the functionality we'll implement in an incremental manner. Many of the stuff has already been implemented. We'll at the moment look at the queen, and in the next module we'll have a look at some of the other functionalities like the en passant and the promotion. Okay, so yeah, we'll just briefly go over the chess piece model. So here each chess piece has an ID. This is of type UUID. We keep a check to see if a piece is moved. We'll keep a check if a piece is alive, what color the piece is, what type the piece is, what possible moves they can make, and we pass a board to the specific piece so that they can check what moves they're able to make and where the image is located on the for each of the pieces. So here we can have a look, for example, through each of the pieces. Before we get into that, we also have specific implementations. For example, with an I king is checked, is checkmate, is stalemate. We also have a bishop that will say whether it's light bishop, what type of bishop it is, whether it's a light square or dark square. In addition to this, we also have an I board. So the board is what represents the physical tiles and each of the squares with its respective piece. So each of these is a tile, and we have functions here to get the tile, set the tile, select the tile. So every time when somebody clicks, we select the specific tile of where we need to go. We're able to deselect all the tiles. We check who is that tile controlled by, and to be able to get all of the pieces by a specific color. We also have an instance to create a copy of it. So this is how we will use interfaces to represent the game state for a game like chess. We also have the implementations of this. So here we have an iChess piece. So the chess piece has all of the implementations with its ID, is it available, what color it is, its specific type of piece that it is, where its image is located. So all of the images are saved under www root images. So here's all of the images. So for example, if you open this up, this is how the black king would look. So each of these are stored and it's mapped to the specific type that it is and whether they've moved or not. Before we get into the available moves, we'll just touch on each of the specific type of piece. So here we have a rook. We'll be having a look at how to implement the queen, and their available moves. We have a pawn. So a pawn, for example, can only move forward, but if it's twice, then it's able to move forward twice. So yeah, this is what we'd look at and how we can see about each of these implementations being different respective to the specific type of piece. So here we have an ID, whether they are live, the color, what type of piece it is, where the image is located, and how the moves go. So yeah, here we have additional examples with the king, what moves they can make, whether they in check, whether they checkmated, whether they're in stalemate, and so forth. The same goes for a bishop. So here we have a chess piece type and a bishop type, and when it's initialized, we can set what type it is. So this is how we're able to use interfaces. So here's an example. For example, if we look at this, it implements iChess piece, but it extends the existing functionality to also allow it to be more specific, because the bishop has specific properties that not all chess pieces have. We could also, for example, use an abstract class for this, where we can derive each of the items. Okay, so let's have a look at how the application is put together in terms of this, and like how this all works. So this is all controlled by the game manager. So the game manager is what basically creates the game and manages moving pieces, undoing, resetting the game, checking if the game is over, updating the scores, and getting the winner. So here, for example, the main functionality here will be to be able to move a piece. So like we saw, the queen does not have an implementation yet on how it has to move. So we'll just briefly have a look at that. So we'll clear out the board and just focus on the queens. So the queens right now is allocated on D1 and D8. Okay, so just to show you guys here, for example, both of these can go and implement this, but when we click on this, oh, it's white move. So yeah, this doesn't have an implementation of this. So this all happens when we try to move a piece. So here's the main functionality about how we go about moving a piece. There is a lot of code behind this, and we'll gradually go through this. But the main focus of this is sort of looking more in terms of how inheritance and interfaces can actually be used to build very complicated systems, and not really as specific on the chess game and all of the rules behind it and the functionality. This is more just to show off the use case and the power of interfaces. So here we'll, for example, have a look. Here we have a validator. So the validator is what checks all of the implementations of where the available moves are. So Okay, without further ado, let's have a look at how a queen is meant to move. So, a queen is very similar to a rook and a bishop. So, here a rook can move horizontally and vertically to any number of squares as long as they're not blocked by that specific square. So, in other words, a rook can move this way and it can move this way, while a bishop can move diagonally in any direction. Even if it's here, it can move backwards in any of the diagonals as long as that square is available. So if here, for example, white's playing now, this can come out in any of the specific directions. So yeah, this can also move in that specific direction, and they cannot move in any other way, if that makes sense. They're only able to move in that specific direction. There's also moves like castleization and stuff like that that will look gradually as we build out the application in future iterations. So the functionality for a rook is already implemented and the functionality of a bishop is already implemented. So let's have a look at the bishop, and then we'll have a look at the rook, and then we'll implement the queen.